This is a February-March 2023 paper, variant 42, 2A, which carried 2 marks. State what is meant by an ideal gas. An ideal gas is a gas that obeys PV proportional to T, where T is the thermodynamic temperature in Kelvin. Part B, a fixed quantity of helium gas is sealed in a container. The helium gas has a pressure of 1.10 times 10 to the power 5 Pascal and a volume of 540 centimeter cube at a temperature of 27 degrees Celsius. The volume of the container is rapidly decreased to 30 centimeter cube. The pressure of the helium gas increases to 6.7 times 10 to the power 6 Pascal and its temperature increases to 742 degrees Celsius as illustrated in figure 2.1. So these are the initial state and this is the final state. This is the pressure, volume and temperature in the initial state. This is the pressure, volume and temperature in the final state. The quantity of helium is fixed. So the number of helium molecules here is the same as the number of helium molecules here. No thermal energy enters or leaves the helium gas during this process. Show that the helium gas behaves as an ideal gas. To show that the gas behaves as an ideal gas, we prove that PV over T is a constant. So this question carries 2 marks. First mark is for evidence of 2 temperature conversion. You must convert 27 degrees Celsius to Kelvin and 742 degrees Celsius to Kelvin. That will carry 1 mark. And then you do 2 calculations using PV over T equals a constant. So you calculate your PV over T for the initial state, which will give you 0.198. And then repeat the calculation for the final state, which will give you also 0.198. Since your PV over T is a constant, the gas involved is an ideal gas. Then the first law of thermodynamics may be expressed as delta U equals to Q plus W. Use the first law of thermodynamics to explain why the temperature of the helium gas increases. You notice that the volume of the gas decreases from 140 to 30 centimeter cube. This shows that work is done on the gas. So W is positive. But then, no thermal energy enters or leaves the helium gas during this process. That means your Q is 0. So when you apply your thermodynamic first law, delta U equals to Q plus W, your Q is 0. Your W is positive. Therefore, delta U equals to a positive value. Since your internal energy increases, the temperature also rises. So to get the 2 marks for this question, the first mark is that work is done on the gas. Number 2, internal energy increases, therefore temperature also rises. Part 3, the average translational kinetic energy EK of a molecule of an ideal gas is given by this formula, where K is the Boltzmann constant and T is the thermodynamic temperature. Calculate the change in the total kinetic energy of the molecules of the helium gas. This question carries 3 marks. These are the 2 states. This is the initial state of the helium gas, and this is a final state as given in the previous page. The number of molecules in both the states are the same because the question says that we have a fixed quantity of helium atoms. So in this question, we do 3 steps. First step is to calculate the total number of molecules by using PV equals to NKT to the initial state. So N equals to PV over KT. You substitute the pressure, the volume, and the temperature at the initial state into the equation. You get 1.435 times 10 to the power 22. The reason we must calculate the total number of molecules because this formula is only for 1 molecule or 1 atoms. Step 2, calculate the change in total EK. the change in total kinetic energy equals to 3/2 K delta T times N. This 3/2 K delta T is to find the change in kinetic energy for one molecule. So when you multiply by N, you get the total change in kinetic energy. So this will give you 3/2. K is 1.38 times 10 minus 23. This will give you the temperature change because the temperature changes from 27 degrees Celsius to 742 degrees Celsius. So the change in temperature will be 742 minus 27 degrees Celsius. Then times the number of molecules. This will give you 212 joules. Then in your part C, the mass of nitrogen gas in another container is 24 grams at the temperature of 27 degrees Celsius. The gas is cooled to its boiling point of minus 196 degrees Celsius. Assume all the gas condenses to a liquid. Then for this change, the specific heat capacity of nitrogen gas is 1.04 kilojoule per kilogram per Kelvin. And then the specific latent heat of vaporization of nitrogen is 199 kilojoule per kilogram. We have to determine the thermal energy removed from the nitrogen gas. First, we draw a diagram to show the change of nitrogen gas at 27 degrees Celsius to nitrogen gas at minus 196 degrees Celsius. The heat energy removed is given by MC theta or MC delta T. Then the nitrogen gas at minus 196 degrees Celsius will condense to form nitrogen liquid at the same temperature. The energy removed will be equals to ml. So to do this question which carry 3 marks, first you must say that the heat energy Q is removed to cool the nitrogen gas from 27 degrees Celsius to 196 degrees Celsius. And when gaseous nitrogen condenses, these are the 2 steps. So we have to use Q equal MC theta for this stage and Q equal ml for this stage. So your delta T is the change in temperature because your nitrogen gas will cool down from 27 degrees Celsius to minus 196 degrees Celsius. So the change in temperature will be 223 degrees Celsius. Then you can use Q, which is the energy removed, equals to MC delta T plus ml. So it'll be 0.024 times 1.04 times the change in temperature, which is 223, plus 0.024 times 199. This will give you 10.3 kilojoule. This is a summary of the facts that you must know to solve this question or this problem. Number 1, you must state that an ideal gas obeys the ideal gas equation. Number 2, convert temperature between Kelvin and degrees Celsius. Number 3, you must be able to recall and use the first law of thermodynamics where delta U equals to Q plus W. Understand that delta U, positive delta U means that the internal energy increases. Negative delta U, negative U represent that the internal energy decreases. Plus Q means that the heat energy is added to the system. Minus Q means that heat energy is removed from the system. Plus W means that work is done to compress the system. Minus W means that work is removed from the system due to expansion. Then number 5, you must be able to relate that the rise in temperature of an object to an increase in its internal energy. Number 6, know that the average kinetic energy of a molecule of an ideal gas is given by this formula, EK equals to 3/2 kT. They must be able to define specific heat capacity and specific latent heat. And you must use C and L in calculations.